All right, hello everyone, welcome. So I wanted to make a quick video about how you can um, work together with the Neutron and the Moog. If these are the two pieces that you own, how you can bring them together and why it makes such a great combo, basically. So yeah, the Neutron is more a MIDI-centric device. It's an expander, so to speak. Expanders are called this way because they're meant to expand your sound palette. That means if you have an existing setup, like you have your DAW or you have some kind of other sequencer, and you just want to get some nice analog sound, you would buy a sequencer instead of buying a gigantic new keyboard synthesizer with all kind of bells and whistles, basically, because you just want to have that sound and you already have something that generates melodies for you. And usually you all work in MIDI, and that's why it's more MIDI centric. But this is semi-modular. That means you can also use a modular sequencer to send pitch information to this device, so it will generate tones based on a modular sequence instead of just listening to MIDI. That's why it makes so special. So the DFAM on the other side, that actually has its own sequencer and its own tempo generator. So it can run at a set speed and plays back melodies at certain pitches, steps and sequence in certain pitches. And it can run by itself. You don't need anything else to tell it what to do, basically. That's why it's less of an expander. But since it lacks a MIDI input, it's more home in the modular world. So it's a good idea to still get both, because they can work really well together and complement each other in many ways. Also, both sound fantastic. There's no doubt about it. So yeah, let's get to it, I would say. So in this demonstration, first of all, ignore all this other fancy flashy light stuff that is here. Yeah, we really only assume we have these two boxes. Yeah, I wrecked them in this machine, but they are still the same thing. So don't worry about it. Also, mine is black. And I have some color accents, and all that is customized by myself because I like it that way. But of course, yours is red, and the labels might be different, and it doesn't look as flashy. But yeah, I think informations are still valid. So let's assume you have a drum machine, yeah? Like the Roland TR-8. The wonderful thing about this machine is that it's not just home in the MIDI world, because like many old machines from Roland, they have a trigger in or a trigger out. This one has a trigger out that is meant to advance sequencer. So on every hit on this drum beat, it will send a pulse on the back that is, of course, just like the rest of the sequence, matching your project or track tempo. So we can use it as a clock generator to replace the one that is already built inside the DFAM. The Neutron on the other side doesn't have a clock input because it doesn't need one. It just generates sound when it's told to do that. But we do have still this MIDI input, and you can send a clock to it. But the only thing that will respond to a clock is this LFO section here. That will then use divisions. Here, when you use the speed dial, right now it is free running, as you can see. Yeah, it's just flashing, and the faster I go, the faster it flashes. So it's free running. Now, when I send a clock here, the same knob will be divisions, like a quarter, an eighth of the current tempo. And that then you can make rhythmic modulation. That is might be something that is also interesting, but not for this demo right now. So we got this cable here. That's my that's going to the amplifier when we're going to play back sounds. You will hear it from this cable. So let's start with the DFAM. So we go here at the top, that's the output. And this is our clock cable from our drum machine, our imaginary one. And that goes into the advanced clock input. And as you just saw, when I pulled out this plug, it now reverted back to the default function, which is running by its own clock. As soon as you connect the clock cable, it will wait for a trigger. And as I just showed you, the drum machine, for example, then would start sending this trigger. Now the next thing is the sequencer here does not have a reset. You might know from your sequencer or from your DAW, when you press play, you always start on the 1. In this case, you don't, because you only have the tempo. You don't have the information when you press play, or that you should reverse the or reset the sequence. There's no reset input on the sequencer. Some sequencers do have one. This one doesn't. So in order to start on the 1 on this 8-step sequencer, is we have to disable the run, so that's not starting. And then you can press this button to advance the sequence. And as you can see, press it multiple times. Then on the very last step, I stop. And then I basically arm the sequencer. And now when a trigger comes, it will start playing. So let's send the trigger. And you can see it's running in time. And now I know that the first step is also the step of my kick, if you're making dance-oriented music. So let's hear a kick to that. And we're not hearing much because I'm not sending. I have muted the first oscillator, so let's bring it in. Basic DFAM sound. Of course, we can bring in the other one. And we can also do some frequency modulation here. Basic stuff, yeah? So that's just a Neutron being clocked by an external source like your drum machine, for example. Now we got this wonderful Neutron here and we want to use it with the DFAM. So the most simple patch that you can do requires 2 cables. One is to send pitch information from our steps that we tweaked to the Neutron and then send those back as audio into the circuitry of the Moog, so it runs through the filters. So basically it becomes a third oscillator. And as you can see here, we have a little mixer. This is the first oscillator, this one. This is the second oscillator, this one. And in the middle, we can add noise. But when we plug something into the external audio input, this will become a volume knob. So you got a 3-channel mixer here, basically. So let's patch that. You're going to take the pitch information, which comes from this output down here. And here in the signal in, the third one. 1, 2, 3. This is oscillator 1 and 2. So you send the same pitch to both oscillators of the Neutron. You can also choose to just use one and use but that's more advanced. So let's just stick to the basics. So now we know when we press play, these will get the same pitch as they are programmed here. Now we need the sound from both oscillators, and here the third output of the signal outside is just the oscillators. I'm ignoring all the rest of the synthesizer. I'm only getting the pure raw oscillator sound from the Neutron. And then we plug it into the X audio input. So if we're gonna play now, still sounds the same. So let me turn down the standard oscillators basically from the DFAM. We only hear clicks, but now let's bring in the Neutron. Quite a different sound, right? course we can change the wave. And we can also blend both oscillators. And we can now use the filter section and the envelope generators to shape the sound. And also the noise mod is still working in this. So you can add a bit of noise to the filtered sound. Or you can just keep it clean. So that's the basic patch, how you can use the Neutron oscillators with your DFAM. So as an additional set of oscillators, basically. So we're not using anything else of the Neutron. We just want to have this raw sound because we like to use our DFAM with 3 oscillators instead of 1. Because of course you can mix. Now when you go a bit further and you take your time using a tuner, you can actually make chord stabs with that. Just a little tip. When you tune them to a chord, basically. So yeah, the next thing, for example, we can also say, okay, that's all fine. I want to use more than just the oscillator. So let's say we have here now just a Neutron. But we want to use, for example, also the filter. So then you go from the filter output. And now I can use this filter. And both filters. But now they're both in low pass, which does not make much sense. So you can just switch it to a high pass, for example. Now you got a dual filter, low pass, high pass, for example. Or band pass, like, I don't know. You get the idea. So that's another cool thing. But okay, now let's say that's all fine, but I just want to play with the Neutron right now. So we keep the pitch patch, but we now want to use the envelopes, and we want to use the built-in amplifier and the overdrive and all that fun stuff. So what we have to do is we have to trigger the envelopes so that they open up, and then the sound of the entire machine will be coming out of the output. So we go out here from the trigger output, so into the envelope gate 1 input. We got gate 1 and gate 2. Thankfully, on a Neutron, gate 1 and gate 2 are normalized. That means you only need to trigger 1. That saves you a cable. You don't need to worry about the multi or something. So just put it in gate 1. And now on every hit on these steps, the envelope is triggered. So we can start playing. And we're not hearing much because, yeah, we don't have any audio source playing anything. So we just get some clicks from the VCA. So okay, next one is we want to have sound. So we're going to take out our recording cable that goes into our mixer and put it here into the output. So what's now happening is we still get the melody, but we now use the amp section and everything. So I can now shape the 4 stages of the ADSR envelope. But sustain does not really do much for us because it's not a gate sequencer. Now the difference between gate and trigger is basically a trigger is just a short pulse, no matter how long you hold down the note on your keyboard if you use one. It will always only be a short impulse that is there to inform the envelope to run its course. So that's all there is to it. When you have a gate sequencer, it will actually send a constant voltage to the gate input of this envelope, and it will keep it open for as long as you want, and that would then allow you to also use the sustain to set the constant level as long as the node is being held. So yeah, we don't have that in this constellation, but I guess we are gonna do some dance music with some punchy bass lines, so we don't need to worry about long held nodes that much, unless we're talking about leads, and this is not a lead setup basically. So okay, we can now use the Neutron synthesizer. We're basically only using the DFAM to be our sequencer. That's basically all that is been done here. So you could replace this with a Quark SQ1, you could use your key step, you could use a beat step to do the very same thing here, and not using MIDI, for example. If you just want to keep it like this, then yeah, it's the same methodology basically. You patch in something into the both voltages, the oscillators I mean, and then you trigger the gate. That's it. So now what you also can do, this also has an external input basically. You could use the DFAM to as an additional sound source for the Neutron, or you could use the what is it, the envelope, for example, from the Neutron, from the DFAM. So as long as the sequencer is running, this also sends triggers to the generators. So while this is running and we're not hearing any sound, constantly voltages or signals are being generated here, regardless if we use them or not. So we can just go in and, for example, take the VC EG, that means envelope generator EG, from the VCA, there's this knob here, and we can use it to basically control the VCA of this synthesizer. You can read it here, it says VCA CV. It's the second row, the fourth input. I got here the slow one. Likewise, you can use the envelope from the Neutron to play the DFAM. It's just this one, yeah. And now we're going to take again our trigger to tell the envelope to do its thing. Okay, to make it noticeable. Now this is the default envelope from the DFAM, super short and clicky. And now we're gonna take the envelope from the Neutron and control the VCA of the DFAM. And now we got an ADSR generator for our DFAM. It's still not gated. But we have a bit more control. And we can also remove clicks if we want. Okay, so like this. And back to normal. Of course, we have two of these outputs, so we can have two different envelopes if we want. That's all cool and stuff. So now we can also say, like, I want to use the delay generator here, this bucket brigade delay. Then we just go into the output, the Neutron. And now we're hearing the Neutron, but we can intercept the signal, or we can step into the signal chain of the Neutron that is currently using the oscillators of the Neutron by patching in an audio signal into the delay input. And now we're just hearing the Neutron again, the DFAM I mean, but we can use the onboard delay generator here. Like this. Or we can also go into the overdrive, for example. Go a bit bright. Or dark. I think the drive, they could have made the drive a little bit better in my opinion. In most situations I try to use it, it only makes it louder. Not really much of a thing, but the tone control is nice, I guess. Yeah, that's how you can bring these two together. Of course, we can now go into modulation. And we just play. Take this output here, and we don't need this one then. If we just want to modulate, we need an LFO for modulation. I mean, we already showed envelope modulation, but we of course can use also the LFO output that is here, either in up and down, bipolar or unipolar. And then we can patch it here into the VCF mod. I mean, it's short for modulation, obviously, but it does not work by default because you have to turn up this level then of VCF modulation. Now I can fasten it, or make it faster, I mean, and change the waveform type. That's one thing. Then also we have sample and hold here. You could, for example, use the clock output, the trigger output, to clock the sample and hold if you want. You can see the clock signal is here being recognized straight away. Generate random voltages if I want. Where is it there? SNH. Also again VCF mod, that's most obvious. Can set up some glide here. I assume a bit tough to hear. Activate all the steps. And as you might be able to hear, it's being modulated to this rhythm or to this tempo, I mean. Every hit now has a different filter frequency. Of course, if you don't use the trigger, this also works. Then you have to set the rate with this knob. That's all that is doing. Okay. So what else? I think that pretty much covers it, I would say. how you can patch them together to become a single unit. Of course, you can use all these other stuff. I don't want to get into too deep. This is just a way that you can use them in two directions. To I don't know, if you want to use two filters, you can have it. If you need an LFO, you can use that. You can also use the sample and hold. You can clock it. You can use the overdrive. You can use the delay. Of course, yeah, as I said, you can also, or you could use the LFO to trigger the envelope, for example. Let's try that. Let's just go here. This is sample and hold, yeah? Okay, let's use the sample and hold and put it in the trigger. Not sure if that works. Voltage ain't right. Let's use the LFO unit, maybe. Yeah. So I set the LFO to be a pulse, and now I can set the tempo, and that will then trigger the DFAM to make a single sound. That's some fun stuff that you can do. Yeah. So yeah, I mean, as you see, it's just a matter of where you place the triggers. You can also, I don't know, take the trigger, run the sequencer, and use the trigger for the envelope. And then you can use that envelope, I don't know, for noise level. And that's interesting, for example, when you plan on making a kick drum. Let's turn down 3 steps on each and just have these 4. Okay, let's pretend this is our... And what I like to do is to turn down the pitch on both, so we get an equal ground and they're not in different pitches. Now I'm just gonna raise the oscillator sound frequency so it becomes audible again. So add a bit of pitch modulation. I'll bring in the second oscillator. Enable hard sync so they both start on the same time. And as you can hear, there's still noise, but so that's how it sounds normal. Bring down the pitches, everything here. Okay, like that. Now filter it out. And now I can use this, for example, this super short, clicky envelope here to add noise. You hear it? Now it's off and now it's on. So you got a little click on your bass drum, basically. And of course, shaping it, it's up to you. Now you can, of course, go further. You can take the output and send it to the drive. Let's go here, overdrive output. Overdrive input. Now it goes here through this circuit, easy peasy. I can tone shape it basically. Or I can go to the output of the main output of the DFAM. And let's patch the output into the VCF in or VCA in. Yeah, VCA in. Ah, okay, now I know what's going on. Because I'm using the envelope, it's also now filtering this one. So to circumvent that, I'm gonna use the VCA envelope from the DFAM because I want the long one and basically overwrite the short clicky one from that I'm using here for the noise. And now I can use the bucket brigade delay. Yeah, okay. If I go into the VCF input, I think I can also use the VCF to further shape my kick drum. Yeah, kind of like that. So yeah, I mean, you can see there's also all sorts of fun possible, and because you can really mix and match all these little modules here and see them as their own thing. So you basically already have a modular system with these two, because if you would be buying modules by itself, you would buy an ADSR and then you would buy a sample and hold, and then would buy some kind of delay and maybe an overdrive or a noise generator, or you need another envelope, you know. So but it's already all here, so you get lots of options, and you don't necessarily need to add additional modules at the very beginning when you're starting out. I myself, for example, I said to myself, I don't want to have a gigantic system, and I just want to have things that complement or enhance these modules, these expanders. So for example, I married the DFAM to a wavetable synthesizer. So I got a digital sound source, then going into my external audio input, and then I have basically two analog oscillators and one digital. And that gives me a range of sound possibilities with just one module and a case, basically. And so yeah, you can keep things simple like that. And also, if you think about how you can make them become a single unit, how much more tweaking possibilities you then have by thinking a little bit outside of the box. And yeah, just have fun patching. So I want to wrap up this video here because I think I'm rambling for way too long already. 34 minutes, but I hope it was informative. You had fun watching, even though it was more of me talking behind the camera. But yeah, I mean, yeah, the knowledge is there. It's here to share. So thanks for watching, and see you guys in the next one. Bye bye.